Hello, my name is Colin Berry. I am the team lead of the Mizzou Student Underwater Robotics Foundation, and I am also the mechanical lead. So today I'm going to be talking to you about the whole design of our robot. So our biggest inspiration for our whole design was our last robot, Subby. It was kind of awful. So we decided to scrap Subby because of all the problems that we had with Subby. Subby was way too large, way too heavy, and was not easy to access the electronics, and there also wasn't a lot of area to add on the parts that we needed to complete the tasks, as well as Subby was made out of aluminum, which was very expensive. So we wanted to work with cheap 3D printed parts. So what we first did was set some constraints for ourselves because Subby, we went overboard. So we first wanted our new robot Jelly to fit within a 62 linear inch box, which is the box that you can take as a checked bag on airlines. So this, we can ensure that Jelly makes it to the competition with us. And we also just thought it was a good practice for real world applications where you and the sub that you're working on will be flown out to places all across the globe, wherever information or data need to be taken. So that was what we first did. So then once we decided on these design constraints, we found the propulsion system that we needed to use. So I talked about this propulsion system in the other video, but we decided on this propulsion system and tried to minimize the amount of space that it used. So we put it on an octagon to ensure that we were kind of making it as small as possible while still functional. So once we got through that propulsion system, we decided to add the electronics bay. So since we knew that the propulsion system was going on an octagon, we put the whole or the electronics bay in a circle on top of it so that we can have cameras in prime spots to see everything in the water, and also to just maximize the amount of space that we have on the octagon, and so that it's easily waterproofable and we can just pull off the top and we have access to all of the electronics that we need to. So once we designed the electronics bay, we knew that we wanted the battery to be close to the electronics bay, but we didn't want to put it inside the electronics bay, first to conserve space, and secondly, we wanted to balance out the center of gravity, so that the center of gravity was closer to the middle of our thrusters, so that our thrusters weren't creating unnecessary torque forces on the sub when it's just trying to move forward or backwards. So the battery went under to put all that weight lower, and then we are just going to connect wires from the battery tube to the electronics bay to power all of our stuff. So once we had that basis of the outline of the sub with all the components that we need to just have a powered sub that can move, we then went on to adding all of the things to complete our tasks. So first, we started with torpedoes. So the torpedoes shooter is just an adaptation of the battery tube mount that we had for mounting the battery tube. So in order to utilize the space better that we have for the battery tube mount, we decided to put 2 independent torpedo shooters in it. That'll help us complete the torpedo tasks. Then once we designed that, we knew that we needed to have air tanks. So the air tanks are also just an adaptation of the battery tube holder. They're clipped in by these 2 clips right here on either side to keep them sturdy. So we're just trying to, and they go right to on the sides of the battery tube right there. So here's the air tank and here's the battery tube. So really just trying to maximize the space that we're using for our subs, so that we can have it as small as possible. So then once we added the air tanks, when we were looking for mechanisms for grabbers, we decided to use a pneumatic grabber to use more of the air that we have on board. So we went with this grabber. So just a pneumatic piston that'll push that pin forward or backwards, open and close it as we need to grab things. Yeah, so that's how we ended up with Jelly. So Jelly is a super compact sub that has everything that we need to do tasks on it. It has hydrophones for picking up data, has the torpedo shooters for the torpedo tasks, 2 grabbers so that we can hold things in one hand while we're manipulating other things. Really just trying to make Jelly as versatile as possible so that we can do anything that we need to do. So once we finished the design of Jelly, we found that Jelly actually fits in 49.25 linear inches, which is about like 12.75 linear inches less than what we can use to ship. So Jelly ended up being super compact, only 18 inches wide, or 18 inches long, 17 inches wide, and 14.25 inches tall. And Jelly only weighs 26 or 29.6 pounds. So it really helps us with scoring, because with the weight scoring, we actually gain 98.9 points just from Jelly's weight. So that really helps us just get points where we can. Also, Jelly's whole design is pretty small, which means it's hydrodynamic. Let me go back here. So the small design makes it hydrodynamic, and with the 8 thrusters makes it really fast. So the whole design is able to let us go from task to task really fast in the water. And with the propulsion system I was talking about, it's easily maneuverable and doesn't provide a lot of drag in the water. Another thing with Jelly is that since we have a large plate of which to put stuff on, Jelly is super easily adaptable. So this grabber mechanism, like the grabber mechanism, is just put onto the plate that Jelly already has. And if we needed to add another mechanism, we have a lot of space elsewhere to add some parts. So Jelly is super adaptable to whatever tasks are thrown at us. And we can keep improving and adapting Jelly to whatever problems come up and whatever we need to do. So Jelly is just super adaptable, really helps us out in a competition where things are constantly changing, but we have the same sub design. And overall, Jelly is just a super cheap robot. So most of the parts on here are 3D printed, designed by us. So yeah, we really knocked it out of the park this year with setting goals for ourselves and not only hitting them, but exceeding them in order to create a robot that is both like efficient at the tasks and is super small, nimble, and easy to get around and carry. So yeah, thank you.